Okay, so looking at this example, I have the depth of a submarine is tracked and modeled by the equation y equals x squared minus 30x plus 125. Looking at this, what can you tell me about the equation? What kind of function do I have? Quadratic, because it's, you have to explain why. Yeah. All right. Now, we're replacing the x's with the x values that they've given us. So they gave us 5, 10, 15, 20, 25. Okay? So whatever you have an x, you're going to replace it with the x value. So for the first one, they did it for us. So they replaced the x with 5. So that's 5 squared minus 30 times 5 plus 125. Okay? If you're doing this math, what do you do first? The exponent, right? So you can do 5 squared, which is 25. Wait, can you do this as well? What's 30 times 5? Okay? And then you can add it all together. Okay? Remember, brackets, if you have anything inside the bracket, you have to do that first. Exponent, multiplication, addition. So in this case, if I add all of these together, they're going to give me a 0. Okay? Now, how about for the second one, for x equals 10?
100.
So what did you do? 10 squared?
Minus 10 times 10 plus 125.
Okay. So that's 100 minus 300 plus 125. I don't think it's 100. What would it be? Anyone got the answer for this?
75.
Friends?
75.
Negative 75. So that's going to be 100 minus 300 plus 125. Okay? For the next one, it's going to be 15 squared minus 30 times 15 plus 125.
Yeah.
What did you get for that?
Negative 100.
Negative 100, yeah? And then 20. Yep. And this one's 0.
0.
So I have to do the first difference, right, to be able, because it's a table of value, this is how I figure out if it's linear or quadratic. So negative 75 take away 0. And negative 100 take away negative 75. And then negative 75 take away negative 100. 25. 0 take away negative 75. 75. Okay? So as you can see, my first difference is not constant. Did I expect that? Yes, I did. Because it's a degree 2. First difference should not be constant. Okay? Now, to do the second difference, I have to take negative 25, take away negative 75, which is 50. 25 take away negative 25. 75 take away 25, 50. Okay? So in this case, the second difference is constant. It's quadratic. Who got this right? Good? Good? Somewhat right? Somewhat? Someone? Yeah? Good. All right. Now, if I want to graph this, remember I'm graphing the x and the y. The x's are going up by 5, and the y's are a little bit, they're in the negative, right? So I have to keep And then I'm gonna go down by negative. I think I can go down by 10. Now, even if you don't graph it like this, and then you go, like you graph it, you're going down by 15 or 20, as long as you keep the same scale going down. So you see what I mean? Like if you start going down by 10, you're gonna have to keep going down by 10. You can't change it in the middle of the question. Okay, I have 5, 0. So 5, 0 is going to be here. Then I have 10, negative 75.
I'll take what you've got.
15, negative 100. Then you see at 20, I'm going back up to the negative 75. And at 25, I go back up to the 0. So you see that this is a clear parabola. What's going on?
No, it's just nothing. I just thought you get like only half of it, but you got the entire thing.
I got the entire thing, yeah. And remember, guys, when you're graphing a parabola or any question, right, if this is going to keep going up, right, that's the direction of it, put arrows at the end just to indicate that this is going to be continuously going up, okay? How does this look like? How does it feel? Are you guys okay with this? Do you guys understand the idea behind it? Okay, so being able to differentiate between linear and quadratic is important. So here is a summary of what we've learned. Okay, so what we've learned is if I have a linear relation, then my equation is gonna look like this. And what would be the degree for this one? Degree 1. The quadratics, what's the degree for the quadratics? 2. So the equation is gonna look different, right? It depends on which form we are looking at, but this is what we call the standard form, okay? So this is the form that we usually use, okay? We haven't talked about the vertex form or the factored form, so this is the standard one. And then you can see right away that it has a degree 2. In the table of value, how can I tell that it's linear? First difference is how about quadratic? For the quadratic? Always. Thank you. You guys can wait till the 13th. I'm used to it. The graph. How would a graph of a linear function look like? Straight line. It can look like a straight line going up, right? Or a straight line going down, as long as it's a straight line. Okay? And then for the parabola, how would it look like? A U. There's two different shapes actually. It's either a U like going up or going down. Okay, so we're gonna talk about more about these shapes. Okay, so opening up or opening down. So questions that I can ask you, okay, on a test, on a quiz, so they could be like this. Examine each question, determine the degree and the type of relation it represents. So that means, is it linear, is it quadratic, or is it neither? Okay? So by looking at this one, the first one, what can you tell me? Degree 1. And type is linear. How about the second one? Degree 3.
It's neither.
Excellent. Right? You see the biggest degree here? The highest degree is degree 3. Right? You always look for your highest degree. Do you guys know what this is called? If like the actual name for it instead of neither? You don't need to know this, but it's called cubic. It's a cubic function. Okay? And how about this? Degree 2. Okay? Okay, so I'm gonna leave you to do these two. They're too much fun to do. I just want you. Why does it go to? I don't know how the graphs look like. Is it clear? Oh yeah, not bad. Okay, so if you look at these graphs, what can you tell me for the first one? It's quadratic, and how do you know it's quadratic?
Because these are you.
What do we call? What did I say? The name of the shape? Parabola. Practice it. Parabola. Can I use decimals instead of fractions? It won't give you the exact answer. Unless your decimals are like to one decimal place when you get the answer. It won't give you an exact answer. Okay. All right, how about the next one? Linear, and then it's a straight line. So the type is linear, and the reason is it's a straight line. Okay? All right, so on the quiz, that is going to happen sometimes, maybe early next week, you're going to have questions similar to these, and you're going to have to identify, plus other stuff that we're going to learn more. But then you're going to have questions like this where you have to identify what the equation is, or if it's linear, quadratic, neither, the shape, y, give me a reason. Okay? So, in that, what I would like you to do right now is I would like you to fill out these tables and then tell me what you can see. Also, for your homework, so you should have 2 booklets, correct?
Yeah.
The booklet we're working on right now, and then the other booklet that says homework. This is the booklet that you can use on your test. Only this booklet that you can use on your test. You can't use my notes on the test. Okay? If you actually fill out the homework booklet, it will help you on the test. Okay? So your homework, it says right here on the orange sheet, day 1, you have page 2 and 3. So your homework is page 2 and 3. Okay? So if you look in your homework booklet, page 2 and 3. Okay? So this page and this page are your homework for tomorrow. Okay? If you have any questions on the homework, I can take them up tomorrow morning. Tomorrow at the beginning of the class. Okay?